Okay, so we were graphing this. Hopefully you got it graphed on your in your notes. But we know what 2 to the x looks like. That's what I have here. The negative flips it upside down, right? Reflects it across the x-axis, and that's what we did here. And then the +1 should move it up 1. All right, so let's look and see. You can always just plot points, but I'd like you to get an idea for what it should look like just by knowing what the general form of the graph looks like and then what the transformations do. If we would put 0 in for x, 2 to the 0 is 1. The opposite of 1 is -1. -1 plus 1 is 0. So yes, it should be going through 0, 0. When we put 1 in, 2 to the first is 2. And then we take the opposite. So -2 plus 1 is -1. So we should have 1, -1. Well, I was just sketching. And then if we put -1 in, 2 to the -1 is a half. -1/2 plus 1 is a half. So anyway, I graphed it on Desmos, don't worry, because I know I'm being sloppy today since I don't have my pen. I missed my pen, I'll find it. Okay, so here on Desmos is where I graphed 1 minus 2 to the x, or -2 to the x plus 1. So see how it's going through 0, 0. It's flipped across here. I'll write, if I graph y equals 2 to the x, right here in the green, then you can see what happened was we reflected it and moved it up 1. It looks a little bit better there. Okay, so all those transformations, the same things happen with an exponential function that happened with a quadratic, square root, absolute value, polynomial, all of them, those transformations all apply. All right. Okay, so the next one I think I have on your graph is 2 to the x plus 1 plus 3, or in your notes, I mean. Think about it. Remember what adding 1 right to the x did? Think about if it was x plus 1 squared plus 3. Wasn't it a horizontal shift to the left 1 and up 3? Remember? Okay, well, that's what's going to happen here. It's going to be a horizontal shift to the left 1 and up 3. So even just thinking about what 2 to the x looks like, I know I'm not graphing this real great, but it should look like this, but shifted to the left 1 and up 3 is what we're thinking should happen, right? So, of course, you would graph it on your graphing calculator, but it helps to know what it should look like. So then if maybe you plugged something in wrong or, typed something in wrong. I usually put 0 in first. 0 plus 1 is 1. 2 to the first is 2, plus 3 is 5. So 0, 1, 2, 3, 4, 5 is where I should be going through. I'll put -1 in. -1 plus 1 is 0. 2 to the 0 is 1, plus 3 is 4. -1, 1, 2, 3, 4. Maybe put 1 in. 1 plus 1 is 2. 2 squared is 4, plus 3 is 7. Okay, so I was a little, obviously I was a little bit off, but we have the idea of how that goes. Sorry. Hopefully you graphed it nicer on yours. All right, so those are graphs of exponential functions. Now we also want to use exponential functions. I want to show you how this works in the real world. Okay, here's a place where we would use an exponential function to model this. In the year 2000, the cost of a loaf of rye bread was $3. Every year after 2000, the cost increased by 5%. Write the cost, C, as a function of the year n. When n equals 0, that corresponds to the year 2000 when we started. Okay, so let's see here. We're saying that when n is 0, the cost was $3. When n is 1, it increased by 5%. Okay, so we're going to have to take 5% of $3. That's 15 cents. So now it's going to be $3.15. In year 2, it increased by 5%. So I take 5% of the 315 and add that to the $3, right? And we get $3, it's 3.1575. After 3 years, it increases by another 5%. Take 5% of that. Okay, like you keep taking 5% over and over. And what happens is your graph, my cost is your initial value times 1 plus your rate to the nth power. Okay, it's 3 times 1.05 to the nth. Okay, so if I would put 0 in there, anything to the 0 power is 1. 3 times 1 is 3. If I put 1 in there, 1.05 times 3 is 315. If I put 2 in there, 1.05 squared times 3. Okay, you just keep, it just kind of keeps going with that same, it's the pattern. Okay, I don't think I actually did the year 2 correctly. It keeps increasing by 5%. So I forgot to add the 3.15. Sorry. But anyway, this function is cost or whatever. Yeah, the exponential function. It always equals the initial value. Okay, let's say A times 1 plus the rate, whatever rate they give you. In this case, it was 5%. Okay, to the nth. It's a general formula. Okay, I know you saw it with like interest when we had principal, etc. So it'll be that same thing, but you take 1 plus whatever rate they give you and raise it to the nth power, and you multiply it by the initial cost. Like here, the initial cost was 3. And that makes sense, right? Because the initial cost is when n is 0. And so then if I take something to the 0 power, that's 1. And then you take 1 times 3. Anyway, the initial cost, well, what's it say? What will the cost be in $20 or in the year 2020? So we put 20 in for n to get that answer. E is our famous number. It's sort of like pi is famous, 3.14159. You know, it's the ratio of any circle's circumference to its diameter. This is a number that was discovered in nature. Okay, E is an irrational number. 2.7182818284590. You know, it just goes on and on and on, just like pi does. Okay, and it's found a lot in exponential situations. Okay, like I said, pi is one of our famous irrational numbers, and E is something that happens when something is continually growing. That we find this number showing up a lot. Okay, so E represents the idea that all continually growing systems are scaled versions of some common rate. We don't have to understand all that. I just wanted you to see where it came from. If you were curious, you can always look up E and its origin and where, you know, how it was discovered by Euler. Okay, so the number E then is on your calculator. 2.718 is fine. Some people estimate it to 2.72. It's obviously that's approximate. It's not exact. Okay. We're going to move now into solving equations with exponential functions. This is saying 2 to what power equals 1/8. In order to do these, you have to get both sides into the same base. So 1/8, I know that 8 is what, 2 cubed? Okay. So it looks like I would actually write 1 over 2 cubed as what, 2 to the negative 3? So the answer here is x equals negative 3. 9 to what power is 3? I'm going to have to write 9 as 3 squared. So I have 3 squared to something equals 3 to the first. When I have a exponent raised to an exponent, I multiply. So this is 3 to the 2x equals 3 to the 1. Once you have the same base on both sides, you really can just set the exponents equal to each other. So 2x equals 1 when x equals a half. That's that answer. X equals a half. And think about it. 9 to the 1/2. Does that equal 3? Yes. 9 to the 1/2 equals 3. E to the negative x. I'm going to rewrite 1 over e as e to the negative 1. So then I see that negative x equals negative 1. When does that happen? When x is 1. Okay, and that makes sense. If I put 1 in here, does e to the negative 1 equal 1 over e? Yes. Here I put a half in for x, 9 to the 1/2, that means square root of 9, that equals 3. If I put negative 3 in for x here, 2 to the negative 3rd, that's 1 over 2 cubed, that's 1/8. Okay. Here's another place where we use the exponential function or an exponential idea. It's interest, okay? The annual interest that you make or the amount that you'll have is equal to the principal or the amount that you put in the bank to start with times 1 plus the interest rate over the number of times it's compounded per year to the NT power. Okay. So if I invest $80,000, how much money will I have after 20 years? Well, if it's compounded annually, then that means once a year. Okay. So 80,000 is my principal. My interest rate is 2%, so I put 0.02 in for R. N is how many times per year am I compounded? I'm 1 time per year. It says annually. That's 1 time per year. And then 1 times T is how many years is it going to be in the bank? We said after 20 years, so 1 times 20. I would do that in my calculator. Quarterly, notice the same thing with the 80,000. 1 plus 0.02. So far, everything's the same. But quarterly means 4 times a year. So it's 4 to the 4 times 20 power. Again, we'll do this on our calculator. Continuously is when we use E. All right, this 1 plus R over N to the N, that goes away, and it's just E. So it's A equals P, 80,000. Whoops, 80,000 is still there. 80,000 e to the 0.02 times 20 power. Okay, so let's see what we get for all those answers. Okay, whoops. Okay, so hopefully this is what you got. And you see that you increase the more you're compounded. Compounded annually, I made 118 grand. Compounded quarterly, 119,000. And compounded continuously, 119,345, a little more hundreds than quarterly. Okay. All right, please just try this one. Pause me for a second and see if you know what all these are without a calculator.